Welcome back to part 2 of me learning the castle lure, and today I already revised some of the things I learned 6 months ago. It was quite a long time, and thank you guys for all the support in the last video, but now I'm going to be more consistent on these latest episodes coming out at least once a week. So let's get into it. So last time when I did this, and by the way, you can find all this documentation in my description. It's on the official Castle Docs website where they put all this information out so people can get the documentation and learn from it. So last time we worked on create, on update, and ended up on message here, but now we're going on to the next one, what is actors and behaviors. So you can only read the actors is every single object and thing, and then behaviors is like the triggering things. So in this case they say my equals a special variable that represents the current actor. Like if you look here where it says my layout rotation, my is itself, it's the thing that's doing this, and if you say anything different, it's gonna be relating to something else but the current actor. And then it says here triggering actor in on message, and this is on the previous one, but it's for sending messages using the script. And then this castle creator actor wall, this is the same thing as in the rules or the logic, but it's just written out like this, where it starts as castle because it's a castle script, and then it says create actor, and actor is capital because the second and every single other word after the first word here is a capital letter at the start. And then wall is the name of the thing, and this is the X coordinate and the Y coordinate. Then we have the closest actor with the tag. That's going to be, as it says here, the closest actor with any tag that you want to put on here. So in this case, I think we're doing something with that. And then you can also say castle actors with tag, and that's, you say the tag in here as well. So it's just like a tell command to tell those specific actors what to do and things like that. So here we have the behavior properties on different actors, and then we say function on create my layout rotation equals 45. So if I change this to, let's say 20, it moves the ground here. So if I say 10, it moves the ground a little bit, but as you can see, it also moves the golf ball holder. So if you look here, we can see that every single time it does this, so 60, the my rotation thing, because this is on the ball, so the my rotation thing only does it for the ball, and the script below here says castle with the closest actor with the tag ground, and it says the layout rotation equals minus 45. That just minuses 45 from 60. So like, let's say we make it 0, this is the original thing, and it's gonna make the ground minus 45. And if we make it, let's say 20, it just makes the ground go more down, and then it's kind of, every time you change the rotation of the golf ball, it's going to change the closest actor with the tag ground by a little bit. So now that that's done, then we go to behavior properties. Any of the behavior properties that can be set from rules can be written in scripts, slingshot, gravity, all of the golf ball, and all those things. So if we look here and we shoot this golf ball, then it has basically low gravity and eventually goes into the hole or wherever you shot. So to create the gravity and make it stronger, we're going to make the value from 0.1 to 1. So now as you can see, the gravity is quite strong. So we make it 0.5, that's also strong. And then we can also change the slingshot speed, what is basically the power you put into the slingshot. So it goes really powerful there, as you can see. But if you do a little bit of a lighter hit, then it hits it way less. So you can just take the behavior properties, what is the properties in the section of any object that are kind of like presets, like you can make it solid, not solid, and you can add a slowdown as well and things like that. So that's basically what they're showing here, and on create because it's created, so that's that function. And if we go down, you can modify the layout of the X and Y and all these things here. The rotation, we've done that for the rotation on this one here. It says my layout rotation, but you can also, if I go back here and I say the X position, it's going to change the X position to 45, and that's too far. But as you can see now, when I change the variable, it moves ever so slightly, and if I change the X position to minus, it'll it'll do the other way. So now if we go to the castle library, in this last section we learned about the closest actor with a tag ground. It shows here. There are a few other useful functions in the castle library. Here's an example of using castle create actor. Try tapping the wall to trigger on message. Note when using the script math random, which is part of Lua math library. We can check the libraries later on, but this math random is a Lua code. So what I'm going to do is I'm going to first learn Lua, and then I'm going to come back to the castle Lua because it's going to make a lot more sense. So here's the Lua Basics. Basically this is just normal Lua, and it's just integrated as well into the castle. So we look at the Lua Basics, and here's the logs. When you add a script to run your deck in the editor, you'll see a log at the bottom of your screen. Logs are useful for figuring out what happens when your code runs. You can print any type of Lua object on any type of Lua object. So this just tells you if you're doing something right. It creates a text into the log what is below on castle when you press play. And the print can be multiple things. You can say print hello, and as you can see here, this is just normal text, so it needs quotation marks to make it a string. And a string is basically anything that's not a number, or if you want to type like a sentence or words, you want to put quotation marks around them. As you can see here, when it says print 3.14, it's numbers, so it doesn't need the quotation marks to make it a string, because in this case it's an integer. And then you can say local x equals 1 to 3, and it's just going to print x, and x, as it was said there, is 1 to 3, so it's going to print 1 to 3 basically. And then local actor equals castle creates actor wall, print actor. So in this case, I'm guessing it would create wall as when you do it. So once the wall's created, it would say wall or whatever its name is. So here's comments. Comments are just when you type 2 dashes, I think. Comments are useful to help other people or you in the future understand your code, and it's a good idea to leave a comment anytime you write complicated code or writing code that you expect to be used by other people. This is a comment. It doesn't change how the code works, and this is multiple line comments. You can make it multiple lines by adding those 2 square brackets and using these 2 hyphens for like a normal comment just at the start. But with this one, I see you have to end it with the square brackets as well. And multiple line, this can go for a lot of lines basically. So here are strings, and this is what I was talking about. This is a string because of course the words in it and the quotation marks, and this is also a string with another type of thing you can use to make a string. And I'm guessing here they're saying you can use the double square brackets to make just a normal string, not only for comments. I've never seen that before. Okay, so combining strings. There are a lot of cases where you want to combine multiple strings. You can do this by adding double dots between 2 strings. Okay, I see. So they used this some time back, but what you can do is just add 2 dots. I'm guessing just 2 full stops between strings. So in this example, we use x string and my layout x. My layout x is a number that automatically gets converted to the string when it's combined with another string. So try moving the character and you can see how the text updates. So if I move the character, it creates a number showing basically the coordinates of where the character is moving and converts it into a string here. But if we look onto the text here, you can say a function on update dt. We learned this from last time, what is just update as often as it can or when it needs to. And then local my text, what I think is just, it doesn't have a dot or anything. I don't think this is a variable, so I don't know. It showed up again. It could be a variable or an official thing, I'm not too sure. But x, and this is the string part, because you can see x is not getting converted to numbers because it's a string, so it's going to remain the same like that. And then double dot my layout dot x, and then castle closest actor with text, and then it says in string, so the text is probably just the name of it, so that's why we put the quotation marks around it. And then text dot content equals my text. So yeah, this just shows the coordinates of the x, what's pretty cool. And text content, probably because it's gonna change the content of the text to be my text, and we made a variable basically here making my text equal x dot dot my layout x. That's why when we changed it here, we said equals my text to convert this into the layout of x. Then library functions. Lua has a library function that works with strings. For example, string reverse is hello. To get back the string, ole. Oh, to reverse the string. Okay, you can see a list of library functions here. So if I click this, it'll show me all the library functions. I'm not going to look at it now, but basically what it did here in this thing, it just reversed it by using the string reverse, because it did the same thing. Everything's the same, and then here it says my text equals string reverse and my text in the brackets, then does the thing where it takes the actual information and put it onto the text by saying close one's text with the tag text, and then just end up reversing it like this. In the last section we saw Lua string library. Lua also has math library with a lot of useful functions. You can see a list of the math library functions here. Here's an example of how to use math round. Try moving your character to see the number is rounded instead of showing a lot of decimal places. This is actually pretty useful and I use this in my game, but this just takes away all the unnecessary decimal spaces to make it look cleaner. So if we look here, it says function on update local rounded x equals my math round to my layout x. So this is, once again, rounded x is the variable, I guess you could say, we're making here. So all it does is just math round it. This is the thing that rounds it, and then in the brackets is the thing we're rounding. Local my text equals x dot dot rounded x. So it just adds the rounded x, what is gonna be this together, and then my text is brought out. So now when we move it, it only shows the whole numbers and no decimal places or where you move. And here's an example of math cosine and sin. I think it's cosine and I don't know what sin is, but to move the character in the circle. This is basically just straight math right here. To make a circle, this looks really cool, I can't lie. But what it does is local current angle equals 0, and then function on update dt current angle equals current angle plus dt. So this, I'm guessing, it just keeps on modifying the current angle to be constantly changing. And then we can say my layout x equals math cosine current angle times 4, and the same with the sin but with the y angle. So these probably do different things to make it move on the y and the x. So if we change it to, let's say, 3, then we can see it makes more of an oval instead of a circle, because it's changing the x to be going around a smaller position. If we do this also for the sin, now it makes a general circle area smaller, and we make this 2, then it makes it another oval but a different way it's going. So if I change the current angle, I think it just modifies where it starts from, but that's pretty cool. And the current angle is in the brackets here because current angle is created here plus the dt. And let's say we make them both sin, it's only gonna do half of both, and it ends up just doing this for some reason. And if we make them both cosine, it does the same thing. But if we take away one, and if we take away the bottom one, it's just gonna slowly move left to right with some smoothing and stuff. So that's kind of how it works. So that's really cool. I've never learned that before, and I always wanted to know how you make a circle with a rotation, because I've seen many people do that. So now we know how to do that. That's pretty cool. And as you can see, you can't really move it because the x and y position is locked to going in a circle all the time. And here's if, else, and else if. In Castle Rule, there's a condition. There's a response called if condition is met, run response. Lua has if statements that work in the same way. In this example, check the character's position and then update the text based on that. Try moving the character to the left and right and see how the text changes. So I'm guessing this does basically, when you move to the left, it's the if, and if you move to the right, else, or something like that. Because if we look here, function on update local rounded x equals math rounded x. So it does the same thing where it shows the x position, and then local my text. Oh, I understand now. Local also just means it creates a local variable. That's what it's doing. And then down here is if rounded x equals 0, then my text equals in the center. So it just takes the layout x and modifies it depending on what number it is. So if we go down here, as you can see, it is double equal sign, meaning it is equal to 0 and not greater than or lower than. Else if rounded x equals or is greater than 0, then my text equals right side. And this is because this is a positive x and the x number keeps on increasing on the right side. On the left side, the x number decreases. So if you check down here again, else my text equals left side, so it changes the text to this. And at the bottom here, we already saw this, but it takes that my text and tells it to put on to the text actor. As you can see, we check the position of the character in two different ways. We check rounded x equals 0 first, and the double equal sign mean the value are equal. Notice that we have to call math round on the number first. Otherwise, it'll be really hard to get the character exactly to 0. So let's just make sure you can actually see the center for some time. And next we check rounded x is greater than 0. Then it'll trigger if rounded x is greater than 0. It will be true even if it's 0.01. Last, we can just have else. That means the first two checks don't pass. We'll run this in the block. So only happens when rounded x doesn't equal 0 or not greater than 0, which means rounded x must be less than 0. And as you can see here, it's the different conditions here. So it first checks if it's the center, then it checks else. If it's not the center, it's gonna do the right side, and then the last resort is just else. If it's not right side, then it's going to be left side. And then we have other operations here. Lua has a few more similar operators, and this one checks if the value is not equal to another value. A lot of programming languages uses exclamation mark equal sign for this operator, so remember, use this in Lua. So I don't know really a lot of places you want to use that specifically, but it has some uses. And this checks if the value is less than another value, and greater than and equal sign checks if the value is greater than or equal to another value, and the same for this one. And less than and equal checks for the value if it's less or equal than another value. Here's an example of using, I think this is estimate or something, using the top one here. When the actor moves too far horizontally, it destroys itself. I guess you could use it like that actually. Never thought about that. So function on update, local rounded x equals math round my layout x. So that's just the rounded it makes. And if rounded is not equal to 0, then castle destroy actor my, and that's just going to destroy itself and then it ends. So if I move too much and it doesn't come 0, so if I get away from the center, it destroys itself. Okay, that's interesting. But if I move up and down, it doesn't do anything, and if I accidentally go too much, it does something. So now at the end here, it just takes us to the actor reference, which just tells us all the different options we can do. So now we could move back to the castle library where we can continue with this, but what I'm going to do is make a quick project using all the things I learned today, and next episode I'll be moving to this. So what I'm going to do is I'm going to hop on castle, I'm going to create a blank deck, and I'm going to quickly make something using the information I learned. Okay, so I've finished making this little game with all the things I learned. I spent like quite a lot of time making this, like somewhere towards 2 to 3 hours or something like that. But this is using mainly from the scripts the cosine and type of thing to make a game. So once I play, you have this red character that you move. This is not scripted how you move it, but as you can see, it creates little spiky balls that rotate using script, and they use the sign of the Y location to move up and down. You must collect the green ones and try to avoid the yellow ones, and that's kind of the main game loop. Once you run into yellow one, you die, and you can press retry, what resets the deck. I also, on the enemy here, I made him have the X cosine, and then for the Y I used the sign, but I did it also with the rotation for him, so he slightly rotates when he moves in a certain direction. And when the character walks into the spiky ball, I also made that a script. So if I go onto the enemy here and I go, there's this sending the script message at the top here for when it needs to create a point, the green one, and a yellow one, what is the shoot. So once we go on the script, we can see that it has the local variables of the moving X to move the cosine, and then the rotate to move the cosine again, but for rotation. So on update, it's gonna do that same thing they used for the circular movement, and then it says my layout X equals cosine times 4, and then I said the rotation is times 10. Then under that, I said castle repeat at interval. That is something I didn't learn, but I looked further in the documentation, and then I found that because I wanted to repeat, let's just repeat every 2 seconds to do this below script. What is random? R equals math random. That is also something we didn't learn in this today, but I went to the documentation. All this does is just creates a number from 1 to 3, and it uses the number to create the chances of making the certain things. So if it equals 1, it's going to create an actor with attack enemy. I was going to tell the actor with attack enemy to create or to send a trigger message shoot, which if we go up here, it says when it gets shoot, it's going to create enemy attack, and does the same thing, but says when it's greater than 1, then it's gonna, and greater than 1 means when it's a 2 or a 3 instead of just a 1, it's gonna send the message of shoot. And here it shows when it gets the that's a shoot for the for point, and the point is gonna be at the top here. It creates an enemy point. So for the balls that move, I just did the same thing here, basically just making the Y sin, and then the rotation from the first one we learned on the previous episode, and I just made that spin, and same thing for this. And then for the character, the code I added here is just when it collides with the bad, what is the bad enemy, what is the yellow one, it sends the script lost, and then it does a specific action down here where when it gets lost, it creates an actor, what's the retry button, and then when you click the retry button, it resets. And this also says when it's collided, this is just not scripted, it's just when it's collided in the script message point gained. I couldn't make that to work, so I just scrapped that, and it just modifies the variable 1 and destroys green ball, and then on retry here, it just resets the map. But that was today's video. Thank you guys so much for watching, and see you guys next time. Bye bye.